Welcome to this tutorial presented to you by Nirvana Foundation. Today we will learn how to design a photodiode based pyrometer. Here is the photodiode based pyrometer designed on a printed circuit board. As you can see, the following components are used. The photodiode, MUA741 op amp, capacitor, resistor and jumper cables are shown. The printed circuit board has been soldered to make the connections. In order to do this, we first design the circuit on Tina.
That gives monthly. So daily you should take it. So you get this running from 40 into 4 is
160.
160 divided by 1000 because it is converted into kilowatt. And we get this can be reduced. Just for understanding, I put certain whatever 40 watts, ceiling fan, table fan. It's all watts only. And then
Purpose of an ADC, we have used an Arduino Uno. As you can see on the board, there are 5 pins for analog input. So we have programmed the output of this to go to any of the analog pins. We have chosen A0. So we connect it to the A0 pin, after which we connect this to a laptop where we use a serial monitor to display the output.
solar requirement is per day only because every day it has to produce. Every day. So these are maximum units you get it actually.
Hello everyone. So in this part of the tutorial, I'll be talking about the limitations of a pyranometer. So I'll be giving you 3 limitations to deal with. So the first limitation is the length of the photodiode. So basically you would essentially want the photodiode to be somewhere out in the field where you can measure the solar irradiation, while you will have to take the output somewhere inside. So the photodiode will have to be somewhere in the field and your output monitor or CLU will have to be somewhere inside. So now the problem with this is the photodiode usually isn't long enough so that you can extend it somewhere outside and you can take the output inside. So this is one limitation. The second limitation is that we use a plus VC and minus VC for the op amp in this experiment, which is 12 volts each. Now, so these batteries are very bulky, which we use, but we'll have to actually sort of solder solder input voltages of plus VC and minus VC into the op amp directly. So this is another limitation. The third limitation is the Teflon cover for your photodiode. So the photodiode usually gets heated up very quickly when kept in the sun. So now to sort of protect the photodiode and to keep its functioning intact, you would have to cover it with a Teflon cover, which is usually very expensive, and this turns out to be another disadvantage of the Pyranometer.